Howdy, it's Miss Kosh, and I got interrupted with the phone call. It was a lovely phone call, and now I'm back to doing math with you. So this is the third video for the trig transformation, and you really should watch the first two first. So let's finish, and let's see if I can get back in the game and figure out what's happening here. So on this one, the grid that I gave you is not really conducive to this problem, to be honest with you. So when I do these by hand, I like to set my own scale. And so what I would probably do is, okay, we know there will be no, and then we were just looking at our, in the previous video, I was looking at this right here. I said that I set this part right here equal to the original parent function asymptotes. And so my asymptotes are now at pi plus 2 pi k. And that tells me my domain is going to not be that. We talked before about how I'm not writing it properly. So go back and watch that video. My range did not change. It's still negative infinity to negative 1. Pick it up again from 1 to infinity. That looks funny, but there you go. What I would probably do if I were graphing this one is I would probably come along and say, I now have a period of 4 pi. My 0... At 0, I have a y value of 1, and then I had an asymptote we just said at pi, and then here comes 2 pi. Something's going to happen there, and then here comes an asymptote at 3 pi, and there would also be an asymptote at negative pi. And I'm going to tell you to graph one period, and this has a y value of 1, and then down here we'd have a y value of negative 1. And so this one is opening up. And this one here at negative 1, at 2 pi, at negative 1, is opening down. And so I would set my scale in a way that fits. But I was trying to have you do this on top of the grid, and so it got a little bit annoying. But there you go. Does that make sense? The midline is still y equals 0. We can look at the extrema. If we want to find all the extrema, they happen every pi. So they're happening at pi k. So I set that theta over, I lied. Yeah, theta over 2 is equal to pi k, right? It was theta over 2. Okay, and so my extrema are now going to be at 2 pi k. So they'd be at 0, they'd be at 2 pi, they'd be at 4 pi, they'd be at 6 pi, and so forth. Okay, cotangent of 3 theta. Hopefully you recognize that this is going to be, hang on. So sorry. This is a horizontal dilation by a factor of 1/3. Okay, so what we know is that or one thing I like to think about is we have the new period is the parent function period over b. Okay, so what's cotangent's parent function? What period does cotangent's parent function have? Oh my goodness. And that's pi over b was 3. So we now have, we're going to do everything we're going to do by pi over 3. We could say, where were my asymptotes initially? They were initially at pi k. So now I have to divide by 3, and so theta would equal, pi over 3k. So there's one still at 0. But now the first asymptote happens at pi over 3. The next one happens at 2 pi over 3. Then we have one at pi. And there's a tickle in my throat. I'm about to cough again. And the 0 is going to be halfway between those. So sometimes I have seen IB math where they give you a grid and they expect you to graph it and they'll tell you a certain domain to graph it on. And so you'd have to keep going and graphing and graphing and graphing depending on how big the domain is and how many periods you have. But I'm kind of tired of it. So there you go. PreCal, it's going to be multiple choice. So the domain is going to be theta is not equal to pi over 3k. The range is still negative infinity to positive infinity. The period we just said was pi over 3. There is no amplitude for cotangent. The asymptotes are at pi over 3k. And now if you want to find the zeros, so the midline is still y equals 0, or the inflection points happen at y equals 0. But they used to be, I lied. 3 theta, they used to happen at, pi over 2 plus pi k. Now, when I divide by 3 or multiply by 1/3, I get theta is equal to pi over 6 plus pi over 3k. And so that's going to show me how often my zeros happen. So it's pi over 6, and then when I add pi over 3, add pi over 3, add pi over 3, and you probably couldn't see what I was doing. I said pi over 6, add pi over 3, add pi over 3, add pi over 3. And there we go. Okay, let's look at this next little bit. I forgot to talk about this before, but the frequency of a sine or cosine curve is the reciprocal of the period. And when we start doing real-world situations in both PreCal and IB, that'll make more sense. So the range of this graph, let's see, -2 to 6. The midline, well, we're going to have to go, if we're at -2 to 6, that's a total distance of 8. So that means I'm going to have to go up 4 to find that midline. And then you'll notice it's 4 units above, so 2 plus 4 gives me 6. 2 minus 4 gives me -2. So my midline is y equals 2. The amplitude is 4. The period, okay, let's see. If I look at, we're going to look at sine, I'm going to use red. 1, 2, 3, 4, 5 are the 5 typical points of one period of sine. And so when I go from 1 to 9, that shows me that my period is 8. The frequency of f is going to be the reciprocal, so 1 over 8. And f was shifted up, how much? Well, that midline is at 2. Okay, so now I want to write an equation as a sine function and then as a cosine function. So in red, I notice if I use these 4, I lied, that's 5 points. If I use these 5 points, then I can say f of theta is equal to, well, what's the amplitude? 4. And notice I went up first, so I don't need to make that a value negative. It can stay positive. And then I'm going to use sine. Okay, my period was 8, but the new period is going to be 2 pi over b. So that tells me I have 8b is equal to 2 pi. Therefore, b is equal to pi over 4. Don't forget the parentheses. We're using theta. I'm more used to using x. I'm trying to wrap my head around the PreCal. AP PreCal likes to use theta a lot. And then we're going to have a shift left or right, and then we're going to have a shift up or down. So we went up 2. And then what did I do? Well, sine typically starts, this point usually is at the origin. So I went right 1 and up. Oh, that was weird. The thing thinks it's smarter than me. I went right 1 and then up 2. And so I have to go right 1, so that becomes a -1 right here. Okay, now let's do a cosine function. You'll notice, too, I write an equation. I didn't write the equation because there are infinitely many equations, and I'll show you what I'm talking about in just a second. So with cosine, I may say, well, let's do 1, 2, 3, 4, 5 points like that. And then I can say this is still f of theta. If I start at the top up there, then it doesn't need a negative. And my period is still 8, so my b value is still pi over 4. I still have a theta, but I'm going to have a shift. I'm going to still shift up 2. But now on this one, I needed to shift. Normally, cosine starts on the at the top up here. And so what did we do? We shifted over 1, 2, 3. So -3. I pulled up Desmos a minute ago. Here it is. And I graphed, okay, I think this is the first equation that I got. And then this, I think, is the second equation I just got. And then I decided, okay, what if instead I look at a negative a value, which means that I was, let's see, and then I could also have a negative cosine, a negative a value with a cosine graph. And when I do that, what my negative with a sine curve means that I was starting here, 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 and here, those 5 points. Okay, hopefully that's not too confusing. But the point is, you can write a ton of different versions of that equation and it would be accurate. Okay, last little bit that I want to talk about with you is find the domain and range of the following. So domain, what's going to affect the domain? Well, what's going to affect the domain is 3 times theta plus pi over 6. It has to be equal to cosecant normally has a domain of not pi k. So let's find the asymptotes first. Oh, so we're not, anyway, this is a little, sorry. Okay. Let's find the asymptotes first. That's what we're doing. And so then I'm going to divide by 3. And then I'm going to subtract pi over 6. Okay, now let me point out to you that if I plug in 1 for k, if I let k equal 1, then I have negative pi over 6 plus pi over 3, which is going to equal positive pi over 6. And so really and truly, these asymptotes, the first positive one would be at a positive pi over 6. And one of my students in IB and HL noticed today, because I taught this in IB, that she asked me, well, do I have to write it this way, the asymptotes, or can I use this? And I said, oh, sure. They end up generating the same set of not just pi over 6, but you can tell me, you could also say theta is equal to positive pi over 6 plus pi over 3k, and that would generate the same set of values either way. The domain ends up being the set theta such that theta is not equal to, let's use the positive one, but I would accept either answer, pi over 6 plus pi over 3k. And then what's my range? Okay, so let's think about that for this. Hang on, let me grab this and give us a little more space to work. Okay, if this is my equation, we start with a gap because the parent function has a gap between from negative 1 to 1 is the gap. Okay, and now this 4 stretches that gap, so then it's going to get a stretch to negative 4 to positive 4. But then we have to shift down 2. So then we shift down 2, so this goes to negative 6, and this goes to positive 2. And so now the range of this graph is going to be negative infinity to negative 6. We include negative 6, we pick it up again from positive 2, and we go to infinity. Super. Okay, so there's domain and range of the first one. Let me switch colors as I do the next one. The nice thing, as soon as you see tangent, range is easy. As soon as you see tangent, it doesn't even matter what other chaos is happening. The range will be negative infinity to positive infinity. Okay, and so now what affects your domain, let's pick another color. How about purple? This will all affect the domain. So I'm going to say, to find my asymptotes, I'm going to say pi over 4 times theta minus 2 has to be equal to, okay, let's think about this. Where does tangent have asymptotes? And hopefully you'll be this quick, pi over 2 plus pi k with a little practice. And now what do I need to do? I need to come along and say, let's multiply everybody by 4 over pi. That looks funny. I'm not used to multiplying by 4 over pi. So that gives us theta minus 2 is equal to 2 plus 4k. The pi is canceled. And then when I add, theta equals 4 plus 4k. I didn't intend to do this, but notice if I start at 4 and then add 4, I can back up. Okay, hang on, let me try that again. If k is equal to negative 1, then I have that theta would imply that theta equals 0. So I can say theta equals 4 plus 4k, which is fine. I don't have any problem with that. Or I can just say theta is equal to 4k. That will generate the same set of asymptotes. So that means my domain, the shortest, easiest way to say is my domain would be the set theta such that theta is not equal to 4k, where k is an element of the integers. And I ran out of space. Did I do the integer stuff before? No, I forgot k's right here. My bad. Okay. There you go. Hopefully that was helpful. These take practice. They have lots of details, and you just have to grind it out. So lock in, ladies and gentlemen, so I don't have to crash out. Comment below if you think I'm funny, and go practice. Good luck.